Fun Science with KidBright. This episode will feature Kid Racer and the Beam KidBright IoT robot. Alright, little racers and kids, we now have a great mission to represent the world and enter the Beam KidBright IoT robot for the Universe Championship. Here, take this.
Wow, what is this?
This is the Beam KidBright IoT robot. You will have to use your skills to assemble, connect, and customize in order for your Beam KidBright IoT robot to win the competition. But first, you must study and learn about this robot first to find out what it is and what are its components. So what are you waiting for? Let's do it! Mission number 1. Getting to know the Beam KidBright IoT robot. The Beam KidBright IoT robot is a car invention that can automatically fun along the designated line. The motor is controlled by an infrared sensor to allow the car to follow the black line. And it can also connect to the KidBright IoT so it can be remotely controlled. The components of the Beam KidBright IoT robot include 2 10 kilo ohm resistors, 4 1 kilo ohm resistors, 2 1N4001 diode, 2 0.1 microfarad capacitors, 2 BC337 transistors, 2 LEDs, 2 BD679 transistors, 2 50 kilo ohm variable resistors, 2 infrared sensors, 2 motors, 2 wheels, front support wheels, battery slot, AA batteries, breadboard, PCB prototype board, power cable, screws, power bank, CD for the car structure, micro USB cable, and a KidBright board. Great! Mission 1 has been completed. Here is your prize, a high-speed motor. Now kids, let's concentrate on our next mission. Mission number 2. Assembling the Beam KidBright IoT robot. Start by placing the infrared sensor onto the PCB prototype board, followed by the 100 ohm resistors, like this. Flip the board and bend the infrared sensor pins to the left, right, and bottom like this. Now, bend the resistor pins upward to touch the infrared sensor's pin that were bent to the left and right, like this. Solder the resistor pins to connect with the infrared sensor pins. Connect a wire, which will be the negative wire, to the board. Flip the board back again and bend the negative wire towards the infrared sensor pins and solder. Next, connect a wire, which will carry the output signal to the board. Flip the board to the other side. Bend the output signal wire towards the infrared sensor pin and solder. Connect a wire, which will be positive wire, to the board. Then flip the board and bend the positive wire towards the pin of the resistor and solder like this. Use diagonal pliers to cut the protruding pins of the equipment. This is the first infrared sensor circuit, but you have to do another set just like this one to use with the motor. Just follow the same procedures. After completing making 2 sets of the infrared sensor circuits, we can start to connect the motor. The 2 power cables, positive and negative wires, must be soldered to the motor like this. Solder the power cables to the second motor as well. Solder the wires to the variable resistor by connecting to the left and middle pins of the resistor like this. Solder the wires to the second variable resistor like this. Okay, let's start connecting the equipment to the breadboard. Start by connecting the BC337 transistor onto the breadboard like this. Place the BD679 transistor on the board to connect its pin 1 or the base to the pin 3 or the emitter of the BC337 transistor. Connect the LED with shorter pin or the cathode negative pin to the middle pin or the collector of the BD679 transistor. Connect the capacitor to the both pins of the diode. Connect the first wire to the pin as the diode and the 1 kilo ohm capacitor with the positive bus like this. Connect the second wire to the middle pin or the collector of the BD679 transistor with a negative bus. Connect the 1 kilo ohm resistor to the middle pin or the base of the BC337 transistor. Connect the third wire to the positive bus and the pin 1 or the collector of BC337 transistor. Connect the variable resistor with the middle pin of the 1 kilo ohm resistor and connect the left pin to the negative bus. Attach the infrared sensor circuit by connecting the middle wire or signal output wire and connect it to the same pin as the 1 kilo ohm resistor and variable resistor. Then connect the rightmost or negative wire to the negative bus and connect the leftmost wire or positive wire to the positive bus. Connect the motor by connecting the first wire to the positive bus and the second cable to the middle pin or the collector of the BD679 transistor. Insert the batteries into the battery slot. Then connect the black wire to the negative bus and connect the red wire to the positive bus. Try testing by using your hand to cover the infrared sensor. If the motor works, that means that we have connected the circuit correctly. Now, let's try connecting the wheels to the motor so we can see the results more clearly. Let's also connect on the other side of the circuit. But first, we have to disconnect the battery slots first. Then connect the electric wires between the negative buses and between the positive buses on both sides of the board. Then connect all devices onto the board by using the same method that was done previously. Try connecting the circuits to see if they are correctly connected or not. Wow, very good! After connecting the circuits, let's now do the car structure. Start by attaching two CDs together by using a thin double-sided tape, and also another two CDs like this. Connect the side of the wheel with the square holes to the motor axis. Secure the wheel axis with a screw and tighten. Do another wheel in the same way. Use glue to attach the motor onto the CD that is tightly sandwiched on both wheels. Attach the front support wheel with the double-sided tape to increase the thickness. Then attach the front support wheel to the bottom of the CD, halfway between the two motors above. Attach the battery slot to the CD on the same side as the front support wheels, with the side with the power cable facing in the same direction as the motor power cable. Use the double-sided adhesive tape to attach it on the breadboard where we have connected the circuit. Then attach it to another pair of CDs that we had made. Attach both parts together with double-sided tape. By having the motor part as the bottom base and the circuit on the breadboard to be the top part of the car, and the side with the infrared sensor to be in front of the car, the side which has the front support wheels. Attach the variable resistor by using the used double-sided adhesive tape onto the upper part of the car for easy adjustment of the infrared sensor settings. Mounted both of the infrared sensor under the car near the front support wheels and ensure that it should not be over 5 mm above the ground. Connect the motor to breadboard by connecting the first wire to positive bus and second wire to the middle pin or the collector of the BD679 transistor. Insert the AA batteries into the battery slot under the car. And connect the red wire to the positive bus and the black wire to the negative bus. Test the motor's rotation by covering the infrared sensor one by one. If the wheel rotates forwards, that means that it is working correctly. However, if the wheels rotate backwards, we would need to switch the motor's cable that is connected to the circuit on the breadboard between the wire connected to the positive bus and the wire that is connected to the middle pin or the collector of the BD679 transistor. Wow, both wheels are now moving forward. That's great. Okay, now let's do a trial to see if the car can follow the line. Whoa, why is it not following the line? Oh, that's fine. We can fine-tune the variable resistor. Look at how the car runs and which side it tends to go. The resistor can be adjusted accordingly, adjusted slowly little by little. There, the car is now running along the line. Very good. Oh, very good. Mission 2 has completed. Here's your prize, a set of cool Mag wheels. So kids, how was your assembling the Beam KidBright IoT robot worked out? Oh, so cool. Let's proceed to the next mission and go to the racetrack. Mission number 3, Beam KidBright IoT robot race. Okay, now we attempt to apply the car to work with KidBright IoT so that we can control it remotely. But first, we have to remove some devices first. Start by pulling out both of the variable resistors. Also, remove both of the infrared sensors out as well. Then, remove the two 1 kilo ohm resistors. Two of the BC337 transistors, and also the two wires connected to the positive bus. Then, reinstall the 1 kilo ohm resistor by connecting it to the same position as pin 1 or the base of the BD679 transistor. Connect the 10 kilo ohm resistor to the positive bus and connect it to the same pin as the previous 1 kilo ohm resistor pin. Next, connect the 1 kilo and 10 kilo ohm resistors to the other side of the breadboard, similarly as the first side. Now, it's time to connect to KidBright. We will need to use a power cable to KidBright and the breadboard. Begin by connecting a black wire with a screw to the KidBright's GND slot. Connect the yellow wire to the output channel 1. Connect the green wire to the output channel 2. Back to our car structure, attach the power bank to the car by inserting it between CD base layers. Then attach the KidBright board to the car by using the double-sided adhesive tape. Connect the green wire of the KidBright board to the circuit on the right side of the breadboard, placing it in the same position as the pins of the 1 kilo and 10 kilo ohm resistors. Connect the yellow wire of the KidBright board to the left circuit of the breadboard by placing it in the same position as the pin of the 1 kilo and 10 kilo ohm resistors. Then take the black wire of the KidBright board and connect it to the negative bus. Then connect the red wire of the battery slot to the positive bus. Connect the black wire of the battery slot and connect it to the negative bus. The wheels will rotate like this. But before our cars can be used, we must first make your Blockly program in the KidBright IDE program on the computer and then upload it to the KidBright board. For those of you who don't have the KidBright IDE yet, you can download it and follow instruction on how to download at worldwideweb.kid-bright.org. Next, let's make your program to control the car. Start by opening the KidBright IDE program and make a Blockly program according to this example. The first part will be the commands to control the left motor. And the part of the commands to display the left arrow on the KidBright LED screen. Next will be part of the commands to control the right motor. And the part of the commands to display the right arrow on the KidBright LED screen. Kids, try to code the correct commands according to the example. Now, use the micro USB cable to connect KidBright to the computer. To set Wi-Fi, type in the SSID and password. Then check the Use IoT box and press OK. Then press Create Program. When finished, press OK. Next, click on QR code. Use your smartphone that already has the KidBright IoT application pre-installed and scan the QR code on the computer screen. Press OK on the smartphone screen. Disconnect the micro USB cable from the computer and connect it to the power bank in order to supply power to the KidBright board. And then connect the power cable from the battery slot with the red wire connected to the positive bus and the black wire connected to the negative bus. Observe on the KidBright board if there are red and green lights being displayed, which shows that all the connections are being made correctly. Try using your smartphone to control the car. Turn right, turn left, turn right, turn left, go forward, turn right, turn left. Wow! Very awesome! Mission 3 has been completed. You are now awarded with the Beam KidBright IoT Robotics Championship Cup. You have now created a worldwide reputation throughout the universe. Excellent! All of you are very brilliant. However, there are still other missions to help other worlds. Stay tuned and don't forget to follow our next clip.